Hello everyone, welcome to the video lecture series on complex variable. I'm Mayur Gohil. Let us begin with the video lecture series, and first topic we shall be dealing in this is the basic formulas of complex numbers. So the basic formulas that would be needed over here are the following. We know already that a complex number z can be written as x plus iy. Okay, so where x is the real part and y is the imaginary part. Having known this, so I'll just write here x is called the real part of z. Okay, it is denoted by re of z, and y is the imaginary part of z, which is known as Im of z. Having known this notation, we also would like to know that z bar is known as x minus iy. Okay, it is the conjugate. Okay, it is called as conjugate of z. So that is the conjugate. Now this was the Cartesian notation. Now z, which is x plus iy, can be expressed in the following form, that is r into e to the power I theta, where this is basically a new concept, where r is nothing but square root of x square plus y square, and theta is nothing but tan inverse of y upon x. This is the basic formula that we have for the complex number. Now, when we say z is equals to r into e to the power I theta, this is called as the polar form. It is called as the polar form. Okay, and this same formula, there is a new version in this, a very important version here, that e to the power I theta, e to the power I theta can be written as cos theta plus I sin theta. This is very important. Then we have a few more important things here which are very important to be noted and remembered throughout. The next important formula that here is cos theta can be written as e to the power I theta plus e to the power minus I theta upon 2. Okay, and there is another important formula, that is saying sin theta. Sin theta can be written as e to the power I theta minus e to the power minus I theta upon 2I. This is the only difference between the two formulas. These are basic complex number formulas that we need to know to solve the further uh, portions that we will come across, the complex variable part. So these are very important. A few important identities related to complex number I. So complex number I has these powers. If we know, it would be good. I is nothing but square root of minus 1. Now some people write I as j, but in mathematics it is generally written always the iota I. But when you go to electrical engineering and all, then I stands for current. So we change the notation there from I to j. That's okay, not a big problem. You just have to have a setup like that. That's nothing crucial. But as far as mathematics is concerned, we shall always keep the notation as I. So here it is I square is nothing but minus 1. Then I cube is nothing but minus of I. And then we have I to the power 4, which is 1. Okay. So these are some very basic formulas related to complex numbers, and their derivative also would be very normally seen. Okay, so these are some important formulas. One more important formula that we can derive is, it's not very important, but we will see it very often in complex variable topic, that is logarithm of complex number. Logarithm of z is nothing but half times logarithm of x square plus y square plus I times tan inverse y by x. Okay, I'll better write here. Just a minute. Let's Let me just shift it a bit, a different place. uh, yeah, it is, let's say it is, I'll just put a separator. Yeah, so the formula is log of z is equal to half of logarithm of x square plus y square plus I times tan inverse y over x. Now this is the formula that is important, and it is going to be seen very often there in complex variable, because of this portion, and this portion will be very frequent there. So these are very important formula that would be needed. Okay, now this is all that we would need from complex number. Let us move on to something called as hyperbolic functions. So for hyperbolic functions that we will need is, the first important formula is the basic definition. Yeah, so I'll write it here with yellow. The first important formula is the basic definition. So the first definition I will say is sin h a x. Sin h a x, this formula definition is e to the power ax minus e to the power minus ax divided by 2. The second formula here is cos h ax. Its definition is e to the power ax plus e to the power minus ax divided by 2. This is the definition. After that, one important identity we will need, that is very standard identity, but it will be useful to us throughout. The first thing is we would need here is this cos h square of x minus sin h square of x is 1. This is the most important hyperbolic identity that will be useful, and let's since we have already taken the minus sign, so let me take you the plus sign. This is again important but may not be useful, but we will still keep it handy. That is sine h square of x is hyperbolic cos h 2x. This is the answer. Hyperbolic cos 2x, okay, or cos h 2x. This is the identity that will be useful. Now what is going to be very important and what is going to be very helpful is this formula, the relationship. So let me write down here the relationships that are important. Relationship between hyperbolic functions and trigonometric functions, okay, and trigonometric functions, the relationships are important. So let us see the first important relationship, that is cos I theta is nothing but cos h of theta. This is the first relationship that will be useful. All throughout we will need to remember this. And there is another important relationship is sine I theta is I sine h theta. These are very important and they will be useful throughout, okay. And let's see some another expansions that are that could be helpful to us are the following. The first expansion that will be there, let's say, just a minute, I'll erase this here. The first one will be there is sine x plus iy. Sine x plus iy, this relationship will be very important, and this will give you the expansion here as sine x cos h y, okay. Then there is plus sign here, then there is I cos x, and then there is sine h of y. This would be very important. Then if you push a minus sign over here, let's say I'll take up a different color. uh, Here I'll take, let's say I'll take a yellow color. If I have, instead of sine x plus iy, if I have minus sign, then here it is going to be the minus. That's it. There's no change and the whole thing remains. So here you have two formulas with you, plus minus, and here also plus minus. Okay, so the next formula comes into the picture is cos x plus iy. So that's going to be cos x cos h y minus, okay, minus, and here it is I times sine x sine y. That is what is there. And then here there is if there is minus here, then it's going to be plus here. So this is how these two formulas are there, and they are very important to us. So the these are going to be often used all across. That was the important factorization or of sine x plus iy, or it is very standard. It's derived from sine a plus b, the basic trigonometry, but this will be helpful to us throughout. Now let us see the another important formula regarding the derivatives that is there. Here we have d by dx of sine h of ax is, if we take the derivative of sine h of ax, we are going to get cos h ax, and it is again here when you take the derivative of ax you get a, so the formula becomes a cos h bracket ax. Okay, always remember that after the hyperbolic function has ended, always put the angle in the brackets. That's very important, whether it is a ordinary trigonometry or the hyperbolic functions. You just always put the angles in the bracket. It will distinguish you, it will help you, and it will keep your answer free from ambiguity. Okay, now the next important formula is d by dx of cos h ax, which will be, unlike the ordinary trigonometry, there is no negative sign over here. It is a sine h of ax. That's just as simple as that. We do not have any different answer over here, and this is what we have. Now we go for the the further part of this, and there can be integration also. Integration can be done easily and it can be derived over here. So integration of sine h of ax dx is 1 upon a cos h ax, and you can write here plus c, but then this plus c constant of integration is can be violated, like it it won't pose much difficulty, so don't worry. Unless there is some constant condition given to us, we don't have to worry regarding the constant a lot of time. So integral cos h of ax dx is going to be 1 upon a sine h ax plus c. That's all. This much is what is required from hyperbolic function to continue with the topic. There is nothing much. So there are few sections. If you want to see them here, the sections are, these are the few sections that are there. So so first is the chunk of the main definition, then some hyperbolic identities which are very important and crucial. I also say that you must know the others, but these would be very handy and helpful. The relationship, extremely important, it will be used very frequently, and these two, expansion of sine x plus iy and cos x plus iy with plus minus sign, you can remember. Then what is important is the derivative and the integration formulas. Okay, now we go to the concept of partial differentiation. So let us see what happens here. See, this is absolutely just same as the derivatives, but only difference here is there are more variables in the function. So rules are going to remain almost the same. There's no change, but the derivatives you have to be little careful while calculating. So let's say if we are given a function f of x comma y as 3xy square, okay, plus 7x raised to 5y, okay, how do we calculate the derivative here? So the first thing is, when we are going to calculate the partial derivative, we have to decide the variable with which the derivative is going to get calculated. So the notation for calculating the derivative here is, it is reverse 6, okay. You just write the 6 in the, you flip the 6 and you write it down, and what it is, dabba f by dabba x. When we, you can have this notation, as well as there can be derivative with respect to y. So this is read as, we read this as partial derivative of f with respect to x, and it is, dabba is the notation, or some people call it dou f over dou x, dabba f over dabba x. That is how it is read. The whole meaning is this: partial derivative of f with respect to x. Now, apart from notations, this was one notation. There are few more good notations also. So this dabba f by dabba x can be also simplified and written here as, it can be simplified and written here as f suffix x. It also means the same thing, only thing is that we need to remember that this is taking derivative with respect to x, okay. Dabba f by dabba x means fx, f suffix x, and you take the derivative. Now let's see how to take the derivative. So what happens here when we are taking the derivative, okay, so I'll write here, when we take the derivative of the function x comma y with respect to x, okay. Now there can be more variables also with respect to x, then uh, that time, or then all other variables, all other variables other than x in the function f x comma y are treated as constants, okay, are treated as constants. This is very important. Once you know this things carefully, then you will be able to take the derivative easily. So the derivative over here, when we go for taking the derivative, let us calculate the derivative. So I'll do with the yellow color now. Let's see. So the derivative here is, it's going to be 3y square is constant, and you take the derivative of x with respect to x, okay. So this is the x in the function, and this is the notation. Okay. Now what happens, 7y will be treated as constant, and we take the derivative of x to the power 5. This is what is there. And after that, when you simplify, what do you get in the answer is 3y square, and the derivative of x with respect to x, it's going to be 1. Okay, plus 7y x raised to 5. X raised to 5, the derivative over here is going to be 5 times x raised to 4. You are taking the derivative with respect to x. Now let us see how to go about the further part. If someone asks us to calculate the derivative over here, which are, let's say if we are asked to find f x x, so this is basically dabba square f over dabba x square. That means the meaning is dabba by dabba x, dabba f by dabba, just a minute, dabba x. So again we are going to do the derivative of whatever answer we have got. We will take its derivative with respect to x. So let's see what happens. So the answer dabba by dabba x, here it is the operator. Now dabba by dabba f by dabba x is what we have to see. So the answer that we got was 3y square plus 7 into 5 will give me 35, right? So 7 into 5 is 35, and here I'll get 35 y x raised to 4. This is the answer. Now when I am going to take the derivative here, see what happens. By the rules of the derivative, it is dabba by dabba x operates on 3y square plus dabba by dabba x operates on 35 y x raised to 4. This is extremely basic. Now what happens here, now see in this function, if we observe here, 3y square is the function, and we are taking derivative with respect to x, so the answer is going to be 0, because what we wrote here, when we are taking the derivative of the function x comma y with respect to x, all other variables other than x in the function are to be treated as the constant. So here in the function, all other variables are to be treated in the as constant. So 3y square is treated as constant, and constant derivative with respect to x is going to be 0. Okay, now see here what we see is that these are going to be treated as constant 35y, but 35y is multiplied with the function of x, so 35y will come outside the operator. So what we will have is 35y and times dabba by dabba x x raised to 4. This gives me, this will give me 35y multiplied by 4 into x raised to 3. This is the derivative. So the final answer here will be 140. 35 times 4 is 140. X cube y. So this is the double derivative, double partial derivative with respect to x. So this is how we calculate the derivative. Now let me show you how to calculate the derivative with respect to y also. I'll just put a partition here. Let's see. Let's do that quickly. So we have a function, let's say f is the function. The same function we'll take, and we'll take the derivative with respect to y. So if we are doing that, that means it is dabba f by dabba y. Now when we want to take the derivative with respect to y, it will give me dabba by dabba y, and the function is 3xy square plus 7x raised to 5 times y. So what it will give me, 3x is treated as constant, so it will come outside. So 3x dabba by dabba y square. Okay, then plus there will be 7x raised to 5 is constant, and then there is dabba y by dabba y. Okay, so on solving we will get here is 3x into 2y, and then here we will get 7x raised to 5, and dabba by dabba y is 1, so that is 1. So my final answer will be 6xy plus 7x raised to 5. That is the partial derivative with respect to y. Okay, so this is how we calculate the partial derivative with respect to y and with respect to x. Now let us go and see how to calculate the partial derivative using UV rule. So now for UV rule, first let us understand what is UV rule for partial derivative, and division rule also, because these are two very important. See, um, here it is basically, if we write here this rule in just derivative notation, there are two important rules. The first rule is UV partial derivative, and the second rule is u upon v rule. Okay, so let me just write here u upon v dash. Now this, both rules are in derivatives. The rules are like this: u into v dash plus v into u dash. This is the first rule. The second rule is u upon v dash. The rule is slightly trickier in notation, so it is v square times v into u dash minus u into v dash. These are the two important rules. Now we are going to do this with partial derivative. Okay, so let us see how to handle them. Let me take up an example here, very small example. We'll see to understand. F of x comma y is, let's say, e to the power 2xy times sine 2x. Okay, so when we are doing the partial derivative, we will have two answers over here, like with which variable we are going to do, if we do with respect to x or we do with respect to y. Okay, so let's see. I'll just change the function and make it a uh, little one, which in which we can have both the examples, otherwise it would help us, this will help us better. Let's say, so this is the function now. let us see how to do the partial derivative. So I'll write here that we will do partial derivative. We do the purple is not a good color to use here. I'll use orange then. We we do partial derivative with respect to x first. Okay, let us see how to do this. So when we go for doing the partial derivative, it will become dabba f by dabba x. So it is now saying partial derivative, instead of x, instead of the function f, we will have e to the power 2xy times sine 2xy. Now see, this is basically over here, this is u and this is v. So as per the notation, dash means the derivative operator wherever we have to take. So the as per that notation, what we will get is u times, right? So instead of u, we will have here, we will get here is e to the power 2xy, right? And then there is u times v dash. V dash meaning the derivative of v, but we are taking partial derivative, so we will say derivative of v with respect to x. So that is going to be partial derivative over here, right? Partial derivative of v with respect to x, and instead of v we have over here sine 2xy. Okay, after that we will go for plus, and then there is v to be written as it is, so it is sine 2xy, and then there is partial derivative with respect to x of which function, u dash is given, so u derivative we have to take with respect to x. So when you take the derivative with respect to x, here it is u, so u is the function as e to the power e to the power 2xy. Now we will go for the partial derivatives. So e to the power 2xy, the derivative of sine is going to be cosine. Okay, sine is cosine and 2xy. Now what happens is we will have to do the further derivative also, because here one very important rule is there which is called chain rule that comes into the picture. Let me just give you, if you take f composite g, like this is the whole process. We'll do with the single variable, then we go for the further one. Then the derivative, if you are taking like this way, then you have here the derivative of function f of gx that you take, and then you also take the derivative of the function which is inside the functions. Okay, so you also take the derivative of gx. So here what is happening is I have taken the function derivative, sine derivative is done, but now I am also supposed to take care of the derivative of 2xy. So for that reason I'll have here derivative of 2xy. Okay, now here there is sine 2xy, then the derivative of e to the power 2xy, it is e to the power 2xy. Now as we did further in the, can we see here the yellow part, we will have the derivative of 2xy again, because it is the function of x. So our final answer will be e to the power 2xy times cos 2xy. And now see, 2xy, 2y is constant and x is the function. So what we will have, 2y outside, derivative of x with respect to x is 1, so answer is 2y. Okay, and then sine 2y, oh sorry, sine 2xy. Okay, sine 2, oh yeah, I'll just write like this, it's better. Sine 2xy, and here you have e to the power 2xy, and again here we have 2y sitting there. Okay, so my final answer for this is e to the power 2xy and 2y taken constant, or you can take common, sorry, 2y which is already there, you take it outside the bracket, and here you will have cos 2xy plus sine 2xy. This is the answer for partial derivative when taken with respect to x. So now let us see how to do the further part. Here we will now see an example how to take the partial derivative with respect to uh, here with respect to y we will do, but we will do for division rule. Let's see how to do that. Let me take up another example here. I'll just separate the whole thing. Let's do with the derivative. For the derivative, let's take up a easy function and a nice one that will help you to understand better. Let's take a function f of x comma y, where it is e raised to xy divided by x plus y. Okay, if now let's see how to do the partial derivative. We want to calculate dabba f by dabba y. How are we going to do about it? This is the mystery, so let us see how to do. Now if we compare, here we have, this is u and this is v. Okay, so that is u upon v there. Now we go for, as per the rule what it is said to us, we will go and do that. So we have dabba f over dabba y, which is equal to, now we do the denominator square, that is what it is said, v square. So v square is, v is x plus y, right? So x plus y the whole square. Okay, now there is x plus y in the beginning. Why? Because v is there, v into u dash. U dash is going to be the derivative, but we are taking the derivative, it's a partial derivative with respect to y. So here I will have, here it is dabba by dabba y of u, so it is e to the power x y minus, okay, and minus u times, u is the numerator, so e to the power xy, then the partial derivative, okay, then there is partial derivative with respect to y of v, like v dash means partial derivative we have to take for the denominator, so it is x plus y. So when I simplify this, I'll get x plus y, and the derivative over here will be e raised to x y times, there will be, now see this xy, wait a minute, yeah, This xy, if you see, okay, is a function of x and y, but we are taking derivative with respect to y, so xy, x is going to be treated as constant. So what I will have here is, if I will have one term extra now because of the chain rule, okay, e to the power function derivative is e to the power function, but we have to take the derivative of the function again. So here it is xy minus, okay, so that minus sign you have there. So here you have is minus e to the power xy. Now the derivative is with respect to y, and x is the constant, so and it is having addition, right? So when you are going to have constants which are there in addition and they are standing alone, so their derivative is 0, and derivative of y with respect to y is 1. Okay, and in the denominator there is nothing to be done, it is just x plus y the whole square. That's it. So final answer will be, we simplify the above answer, x plus y times e to the power xy, and here the answer is x because x will come outside and y will remain in, so dabba y by dabba y is 1, and minus e to the power xy over x plus y square. That's it. That's the final answer for our differentiation. Okay, so this is how partial differentiation is done in the whole concept, and that's what is basic thing required. What are few important rules in partial differentiation? They are going to be uv rule, u by v rule, and the composite rule. So if you are comfortable with all this, then you will find all these things very easy. Please go through these two examples. These are very crucial and they are very easy to understand. I hope this will help you to, get the hold of the concept, and please keep on doing these again and again and again, so they will brush up your concepts a lot. Okay, so I hope this whole prerequisite topic benefits each one of you immensely, and you find this easy as we grow in the concept. Till then, thank you, keep solving good amount of mathematics. I'll see you in the next video lecture.